Okay, everybody, we're working out of 5.8 today, which is all about graphing polynomials. If we look at our section on graphing polynomials, I'm really going to focus in on the questions that are related to testing, which is essentially 3 through 12. I'm going to look today at problem number 7 and problem number 9. Those are going to be the two that we look at. Number 7 has the function h of x, but we'll use f of x because I already started writing it down, equals 4 parentheses x plus 1 x plus 2 x minus 1. So this is my polynomial. I need to go through the process to be able to find all of its key important pieces of information. I start with the leading coefficient, which in this case is just the 4 that's out there, right out in front. The next thing I want to find is what's called the degree. To find the degree, I'm going to look at what would happen if I FOILed all of this together. If I FOIL these first two parentheses together, I get x squared plus some number of x's plus the constant. But I'd really be focused on the x squared part from these two. Then if I take that and I distribute it further, I'm going to get an x cubed out of all of this. And so I'm thinking that the degree is 3. Important to realize that the leading coefficient, what matters about it is whether it's positive or negative. So that's positive, and the degree, we care whether it's odd or even, which in this case it's odd because 3 is an odd number. What that does for me is it tells me everything I need to know about the end behavior, or where do the arrows point when this is all said and done. Well, the positive tells me that the right-hand side has to point up. The odd tells me that the right side disagrees with the left side. So since the right side points up, the left side will point down. And that puts us to where we're looking for the zeros of the polynomial. Well, this first parenthesis would be made 0 by the number -1. In the middle, I'd have a -2. And on the far right, I'd have a +1. So here I have 3 zeros, which works really well with the degree of 3. It tells me that all of my zeros are real numbers, which makes it easier to graph. Then I look for multiplicity. Now multiplicity occurs if there's a square on a parenthesis or if a parenthesis is repeated. I don't see any of these parentheses being repeated, which means none of these zeros show up a multiple number of times. So we'll say NA, not applicable for this problem. And then, okay, and so the last thing we need to talk about is the turning points. How many turning points should this have? We always go to the degree and we subtract 1. The degree is 3, so we're going to subtract 1. That gives us a possibility of having 2 turning points. All we have left to do now is produce the graph. So there's my y-axis, there's my x-axis. I'm going to come out here on my x-axis and I'm going to plot the points -1 and -2, and over here I'll plot the point +1. So there's my point there, there, and there. And now this is going to be a little squirrely for us, but I'm also going to use my end behavior, which says it's up on the right, down on the left. And now I should be able to just connect all the points. As I come up to the first 0, I always want to see, do I get to cross it or is there multiplicity? With no multiplicities, every one of these points should just get passed right through. And so I'm going to pass through here and pass through here. Big question is, did my arrows work out? Am I in the places I was supposed to be at the end? And I am, so I'm good to go. Let's also look, I said, at number 9, which has f of x equals 2 parentheses x plus 2 quantity squared, x plus 4 quantity squared. I'm going to go through the same series of questions. The leading coefficient here would be 2, which is positive. The degree of the polynomial, well, there's 2 of these. So this is really x squared here. There's 2 of these because of the square, so x squared. X squared and x squared, that's x to the 4th, which is even. That tells me that my end behavior, positive, tells me the right-hand side goes up. The fact that it's even tells me that, like a pair of socks, the arrows go together. Then I want to find the zeros. Well, in the first parenthesis, I have a negative 2. In the second parentheses, I'd have a negative 4. The multiplicity occurs because there are 2 of these parentheses, x plus 2, x plus 2. And there's also x plus 4, x plus 4. What this means is the value negative 2 comes from 2 different places. So negative 2 has a multiplicity. Consequently, so does the negative 4. Last but not least, my turning points. Since the degree is 4, the turning points should be 3. And I'm ready to produce this graph. And this is very similar to what you'll see when you take the test for this part of the test. 1, 2, 3, 4. So I'll put a dot there at negative 4, a dot there at 2. My end behavior is up on both sides, so up here and up here. Then as I come down, come to that point, I know I'm not allowed to cross here, so I'm forced to come back up because of the multiplicity. The multiplicity at negative 4 forces me to turn around. But then I'm going to have to come back to touch the negative 2. Again, with a multiplicity, I'm not allowed to cross at that point. And so I get this W shape over here on the left. Okay? Well, that's really all graphing polynomials takes, and I hope that answering those 6 questions will really help you be prepared to answer these graphs accurately. Also, keep in mind, you can throw any and all of these into the graphing calculator to assist you with the process. So good luck, and we'll see you in class.